Into exercise 1.2, every irrational number is a real number. Is that true or not? Real numbers are divided into rational, right? So what is the rational form? It is Q, right? And we have irrational, correct? Or you can do R minus Q. What is the correct representation? If you have an irrational number, the correct way of writing an irrational number is R minus Q. Why R minus Q? From the real numbers, you're removing all the rational numbers, okay? So every irrational number, is it a real number? Every irrational, is it real? Yes, right? Every irrational number is a real number, correct? So that is true, correct? Is it under? Yes. So I can say, yes, every irrational number is a real number, will be true, okay? Every rational number is also a real number? Yes. So always draw, it's much easier. Can I say every real number is a rational number? No, there are irrational numbers. Correct, no? Can I say every real number is an irrational number? No, there are rational numbers. So this is the logic. You have to always draw for you to understand better. Then define what is a irrational number. Define what is real numbers. Then you can state, yes, as irrational numbers are on the number line, all numbers on the number line is a real number. You can say that, right? Irrational numbers are on a number line. All the numbers are on the number line are real numbers. That can also be said. It's up to you how to define it. Now, every point on the number line is of the form root m, where m is a natural number. Okay. So how can we do this? Very simple. What we need to do is let's just draw a number line. We'll try to understand. So we have a number line. Okay. So let's write 0, 1, 2, 3, 4. Okay. Then minus 1, minus 2, minus 3, and so on. Okay. Every point on the number line is of the form root m. Okay. So we have 2. What is 2? Can I write it in the form root of something? Yes, root 4 is 2. What about here? 3. 3 can be written as root of 9. Correct now? Yes. But what about the negative numbers? Can I write it root of anything? No, right? Minus 1, minus 2, right? Can we write it as root of anything? Even 1 I can write root of 1, right? But minus, negative numbers cannot be written in root m. Negative numbers are also on the number line. So this is false, right? Every point on the number line is of the form root m is false. Negative numbers, can we write like this? I can say negative numbers cannot be written in root m form, right? We haven't learned that, correct? Written in root m form. So you have to state that, and that's why it's false. Okay. All right. Next question. Every real number is a rational number. Every real number, is it an irrational number? Again, I'm asking, every real number, is it an irrational number? No. Real numbers have rational and irrational, right? Real is rational and irrational. So every real number cannot be an irrational number. Every irrational number is a real number, but every real number cannot be irrational because there is rational also. That is the logic here. So I have to say, no, there is rational numbers as well. Real numbers are of two types, rational and irrational. So all real numbers are not irrational. Some of them can be rational, right? So this is what you have to state. Clear? So I'll repeat again. Every real number is an irrational number is false. Why? Because real numbers are irrational and rational, two types. So every real number, is it irrational? No, right? Every real number is rational or irrational, correct? That is what you have to state. All right. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is rational. Okay. So let's try to understand here. So as per the question, let's take square roots of all positive integers irrational. Okay. So we'll take a number. Let's say take a number 4. Okay. 4 is what? 4 is a positive integer. 4 is what? A positive integer. Correct? Positive integer. How do I write integer? Z, right? Positive Z, or I can say positive integer. Now root 4 is how much? Root 4 is 2. Correct? Root 4 is 2. 2 is what? 2 is a rational number, right? So this is an example of a square root of a number that is a rational number. Simple, right? Root 4 is 2. So here we go. We can say square root of a number is a rational number. So this is what you have to understand. So every square root is not an irrational number, right? Root p is always not an irrational number, right? Root 2, root 3, root 5 is, but root 4 is not, correct? This is what we need to state. Now 1.2 represent root 5 on the number line. How did we do this? We'll do step by step, okay? So there are multiple methods I have discussed in the starting on root x, right? Plot root x. If you have not watched it, please watch. Root x on a number line we have already discussed. You can go check up the chapter. Root x on a number line. This is for in which case? This is when I represent root 7.5 and all those things, okay? So in those cases, you might need this, okay? Root of decimal points. But root 5, there is another method. What is this other method? How do I plot root 5 on a number line? Let's look into it. So if you think about Pythagoras theorem, let's try to plot root 5 using Pythagoras theorem on the hypotenuse, okay? So when will root 5 be on the hypotenuse of a right angle triangle? That's what you have to think. When is root 5 as the hypotenuse of a right angled triangle, right? So what is the Pythagoras theorem? AB square plus BC square is equal to AC square, right? So what do we have? AC. AC is root 5, correct? Now AC is root 5. So AC is what? AC is equal to root of AB square plus BC square, right? Okay. So I need two numbers whose squared and root is equal to root 5. Okay. So I need that be equal to root 5. What should be equal to root 5? AB's root of AB square plus BC square should be equal to root 5. So 5 should be AB square plus BC square, correct? So what will be the value? Let's say I take 1 centimeter. AB is 1. So if AB is 1, what is BC? BC is 2 square. Think about it. What happens? 2 square is 4. 1 plus 4 is 5. Okay. So like that, I know this has to be 2. That is just one way of doing it, right? So either 1 centimeter and 2 centimeter I take, I can get AC as the 5 centimeter. Root 5, right? Not 5, root 5. So 1 square plus 2 square, the whole root is 5. This is the logic, okay? So how do we apply this on a number line? Let's take a number line. We have a number line, we have 0, okay? I can take AB 1 centimeter or I can take 2 centimeter. It is up to me. Suppose if I take 2 centimeter, 1, 2, okay? I took 2 centimeter. So I'm plotting 2 centimeter. Let me just change the ink. I'm drawing 2 centimeter first. Perfect. Sorry about that. Yeah, 2 centimeter first. So after this, what am I going to do? I'm going to draw a perpendicular, correct? How much is the perpendicular? Perpendicular is 1 centimeter. Perpendicular is 1 centimeter because AB is 1, this is 2, right? So 2 and 1. So this much is how much? 2 and this is 1. Now join these 2 points. Once I join these 2 points, what is the measurement? Measurement will be root 5, correct? Now after I get that point, let's say this point is B, okay? I take the point down using an arc. So this measurement from here till this point, right? This point till that point, what do we have? That is our value of root 5. This root 5, how am I putting it down? I'm taking O as the point, right? OB as the measurement, marking it on the number line. So the point here, this point will be what? That point here will be the root 5 on the number line, right? 0 to that point. So I can say, let's say that point is P. So OP is equal to how much? Root 5. Is this clear? This is how you have to plot or represent a number on the number line, okay? We'll do more questions. We'll do root 3, root 4 and so on, okay? So let's try to understand how we can do more type of questions, okay? So let's see. We have something called a square root spiral. This is a trick I want to discuss with you guys, okay? Suppose if I want to mark root 2, okay? What should be my height and base of the right angle triangle? So if you look, root 1 and 1 square plus 1 square is how much? 2. So the root 2 is how much? I need 1 centimeter distance and 1 centimeter height. Very simple, correct? I can get root 2. And same way, if I get root 2, If I take root 2 as the base, then I take 1 centimeter height, I get root 3. Now if I take root 3 as the base, I take 1 centimeter, I'll get root 4. If I take 1 centimeter again height and root 4 as the base, I'll get root 5, root 6, root 7, root 8, root 9, and so on. So like that, I can create the spiral, and all the hypotenuse here, all the hypotenuse of each of these right angle triangle, all the hypotenuse, what can you understand? All the hypotenuse here is the next value, root 10, root 11, root 12, and so on. So every height is how much? 1 centimeter. This square root spiral logic can be used to find the value of, or the length of, root 2, root 3, root 4. What are these? Irrational numbers which has radical. Root value is called radicals. So which has root 2, root 3, root 5, root 6. We can easily find using square root spiral. So let's try to understand how this works. We'll try a few questions on these very soon. So I'll discuss these extra questions in the example set, okay, which is attached below. So in the examples, we'll try to draw different type of root 2, root 3, root 5 and mark them on the number line. Okay, we'll do those in the example set. All right.